A new object appears in the sky, and at first it looks like the kind of discovery astronomers make all the time. Another point of light, another orbit to calculate, another entry to add to a growing catalog. Then the numbers stop fitting that assumption. In 2017, astronomers detect a fast-moving object and trace its path through the solar system. The more closely they examine its trajectory, the more unsettling the picture becomes. This object did not begin its journey here. By the time that realization arrives, the situation has already changed. The visitor is no longer approaching, it is already leaving. The most valuable observations may already belong to the past. While researchers work to understand what they are looking at, the object continues racing away from the sun. Every passing day carries it farther from view. The period when it was closest, brightest, and easiest to study is already gone. The familiar expectation collapses. This is not a discovery that can wait for careful planning and years of observation. Something truly foreign has entered the solar system, and humanity notices it only as the opportunity begins to disappear. The question is, how much can still be learned before it vanishes forever? The race begins immediately. Telescopes around the world turn toward the object, collecting every observation they can. Images arrive. Measurements arrive. Tracking data accumulates. But each new observation comes with the same problem. The target is getting farther away. The object is moving so fast that every passing day increases its distance from Earth. With each observation window, it appears slightly smaller, slightly fainter, slightly harder to study than it was before. Normally, that would not create a crisis. When something important is discovered, astronomers can organize follow-up observations, compare results, and gradually build confidence over time. This time is the one thing they do not have. The object does not remain available while researchers work through the usual process. It keeps leaving. Every delay permanently removes information that can never be recovered. Every missed opportunity becomes a closed door. The familiar rhythm of scientific investigation starts breaking down. There is no guarantee that future telescopes will see more than current ones. Waiting does not improve the situation. Waiting makes the target worse. The challenge is no longer finding the object or proving that it exists. The challenge is extracting enough information while observation is still possible, before distance and darkness reduce humanity's first known interstellar visitor to a point too small to reveal anything at all. Observations continue arriving from multiple observatories. Night after night, the object is tracked across the sky. Its position is measured. Its brightness is recorded. New data is added to the growing collection before the opportunity disappears. For the first time since the discovery, the pressure begins to ease. The object is still leaving, but it is no longer just a fleeting point of light. Researchers now have repeated observations from different locations gathered over multiple observation windows. Instead of chasing a mystery that appeared without warning, they are starting to assemble a picture. The measurements begin to line up. What looked like a disappearing mystery starts behaving like a recognizable object. Observatories separated by thousands of miles see the same thing. The trajectory remains consistent. The observations support one another. For the first time since the discovery, it seems possible that the mystery is shrinking. The visitor appears unusual, but not incomprehensible. A preliminary interpretation begins to take shape. The visitor may simply be an unusual natural object from another star. Rare, unexpected, but still part of a universe that behaves according to familiar rules. For a moment, that possibility feels reassuring. Maybe enough information was captured in time. Maybe the object is strange, but not beyond explanation. And if that conclusion is correct, the remaining observation should continue strengthening it. The picture holds together only until the data is examined more closely. Then the reassuring version of the story begins to crack. As researchers continue comparing observations, small details begin pulling in different directions. The object's brightness does not remain steady. It brightens and dims so dramatically that the simple picture begins to break apart. Whatever is tumbling through space appears far more extreme than researchers first assumed. That alone would not destroy confidence. Unusual objects exist. Strange shapes can still belong to natural objects. Then attention shifts to the object's motion. As astronomers refine its trajectory, they find something uncomfortable. Gravity appears to explain most of what the object is doing, but not quite all of it. A small additional acceleration seems to be present. The object is not following the expected path perfectly. Researchers look for a simple explanation. If material is streaming away from the object, that activity could alter its motion. Yet no clear cometary activity appears in the data. The problem changes immediately. The object itself is no longer the center of the investigation. The missing information is every image, every measurement, every recorded moment is examined again. No new evidence is coming, and that creates a new pressure. The questions are arriving after the opportunity to investigate them properly is already disappearing. The object is still moving away. The chance to gather decisive new observations is shrinking. The moment when verification was easiest has already passed, leaving the most important uncertainties behind. The object keeps moving away. The data stays behind. Long after the visitor becomes too distant for meaningful study, researchers are still working through the small collection of measurements captured during its brief passage through the solar system. The object itself is no longer available to answer new questions. Everything depends on what was captured before it disappeared into the darkness. That changes the meaning of the encounter. At first, the event seemed to be the discovery of a mysterious object entering the solar system. In reality, it exposed something else. Oumuamua was detected only after it had already passed through the inner solar system. The most valuable observation period was already ending before anyone understood how important the object might become. The consequence extends far beyond a single visitor. If another interstellar object arrives tomorrow, the same race may begin again. An object can appear, become visible, generate critical questions, and continue on its way before definitive answers are possible. The limiting factor is not necessarily the object itself. It is whether enough time exists to recognize what has arrived and respond before the opportunity disappears. In that sense, Oumuamua is not primarily a mystery about what entered the solar system. It is a warning about how quickly an important discovery can move beyond our reach. Humanity's first known interstellar visitor did not simply raise difficult questions. It revealed how easily those questions can arrive after the best chance to answer them is already gone. By then, the visitor is already on its way home to the darkness.